Today I'm taking apart a couple of pedals that I bought on wish.com for no good reason. This is the inside of the compressor pedal, and it's made up of two circuit boards and they are connected via a header and some pins, so they sit in two halves of the metal case and they just slot together. It's very simple. This is input and output jack socket, and the switch, which is standard on a guitar effect pedal, it's what's known as a bypass switch. And the reason is a lot of the circuits that I've built to sort of do distortion or whatever, they don't have a bypass. So you turn them on, you have the distortion effect, you turn them off, you have silence. But these bypass switches have enough contacts that you can actually wire in the clean signal so that at the right switch position you just pass the clean signal without any distortion and without closing off the sound completely. So that's really useful. So we've got input that takes the 9 volts, and the thing to remember with effect pedals is they use a center negative adapter, which is fairly unusual, but it's the standard for effects pedals. And there's a capacitor here, so this is some sort of power filtering on the input. And there's also a pretty chunky diode, and I think this is probably a Zener diode, so that if we end up in an overcurrent situation, if the voltage that's coming into here is actually too much, this will break down and let the power go to ground so that we don't fry the circuit. Okay, so the second slightly more complicated circuit board, we have our sustain, level and attack knobs, and these are just potentiometers. These two are inverse logs, so that they're kind of the right way around and the right profile to sound natural to the human ear, so they're like an audio taper part. This is just linear, just the level, so it's just a volume control. So we have a lot of surface mount components, like it's pretty simple: resistors, capacitors, diodes, transistors. I think this collection of components here, particularly around the transistors, this is the input buffering stage. What that means is when you plug an input into a circuit, you don't want to affect the signal that you're putting in. Essentially, you want your input to be high impedance. Otherwise, you start to lose energy from your input, particularly your high frequencies, if it's an impedance issue. And so what this does is it uses a transistor as an input buffer, and I'll try and demonstrate. So we have a supply voltage. We have some sort of audio signal coming in to a transistor. And because this is wired up to the supply voltage, it can essentially make an electrical copy of this audio input. This is what's known as emitter follower. So we're recreating the input as the output to the transistor, but what's really important here is this gives a level of isolation, so the input is no longer affected by any of the circuitry that's downstream of this buffer. So essentially we're protecting the input against being affected by later circuitry. So in that sense, it's giving us a high impedance input, and our input isn't losing high frequencies. So as I mentioned, this pedal is a compressor, and the bulk of the work is being done by this chip here. And I had to Google this one. This is the LM13700, and there are a couple of op amps in this package. Now, the way a compressor works is it reduces the dynamic range, and what that means is that low amplitude signals become more similar in amplitude to high amplitude signals. And the reason that we have op amps in here is op amps are excellent for comparing signals and making them more similar. So this is inside the EQ. It's got these really lovely linear pots, these faders, which are very satisfying. But what's annoying is, unlike the compressor, the two boards are actually soldered together, so I'm going to need to do some desoldering to get the boards apart to actually look at what the brains behind this module. So to desolder, I'm going to use some of this solder paste because it just helps everything come. But I think it lowers the temperature, which helps the solder flow. It's a flux paste. And I'm going to use that in conjunction with some solder wick to mop up some of the solder, and then hopefully I can just pull apart the boards. So I'm just gently encouraging the solder on these pins to flow into the copper braid. And it probably goes without saying, but the copper braid is an excellent conductor of heat, so I'm trying to keep my fingers away while I'm actually doing the desoldering. Yeah, I pretty much gave up trying to do it properly. Desoldering was proving very difficult, so I just cut the pins. Yeah, not ideal. Anyway, we can have a look inside now. Possibly it's not surprising, but there's a bunch of capacitors and resistors. I assume that what they're doing is setting the filter bands that divide this up into the portions of the graphic equalizer. These chips here are just op amps, so I think what's happening is that these combinations of resistors and capacitors are splitting out frequencies, which are then being passed to the op amps, and then the op amps will be sort of cutting or boosting frequencies depending on how much signal is being fed to them via the fader on the front of the box. And that's pretty much it. That's what I destroyed it for. So that was a bit like Robot Wars. Only one survived victorious to live to fight another day. But I hope that was at least interesting to have a quick look inside and see what's going on inside these cheap pedals.